Okay, so in this section of 6.1, we're going to be factoring by grouping. Now this is going to turn out to be a very powerful technique to help us factor more complex polynomials. Here, let's start with one. 15xz plus 15yz minus 5xy minus 5y squared. Okay, the challenge is to factor this. Well, the first thing I'm going to notice is that I have my four terms, and there is something common to the four terms, isn't there? It's the number 5. So the first thing I'm going to do is factor out a 5 and see what I'm left with. The first term becomes 3xz plus 3yz minus xy minus y squared. What I want you to notice is that there's four terms here. What we typically do is we group the first two and then group the second two. So when you have an expression, particularly in this chapter, if you have expression with four terms in it and you're asked to factor that, try this factoring by grouping. Okay, let's take the first two terms. I'm going to rewrite this whole thing. Take the first two terms. I'm going to be preserving my negative sign inside there. Notice how I put that positive sign out front. Take a look at the first of the parenthetical expressions, this first binomial. There's a common stuff in there. Yep, I see a 3 and a z. And what's left over at the end? X plus y. Take a look at this term here. Now what I want to do is I'm trying to go backwards on this distributive property, if you will. So what I'm going to end up with is something, and I want to have the same thing here. I want to have x plus y. Now, is there something that I can pull out of this binomial right here to leave behind x plus y? Well, yeah, it certainly turns out that I can pull out a negative y, can't I? Okay, now notice I have x plus y here and x plus y here. I'm going to continue on doing my reverse distributive property, if you will. So it's going to be 5. I'm going to take out that x plus y. And what do I have left behind? Well, the x plus y was multiplied by a 3z, and it was multiplied by a negative y. So I'm going to tell you that this binomial times this binomial actually works backward up to this binomial here. Because what do? We take the 3z by the x plus y, take the minus y by the x plus y, and eventually we'll come out to this version here. So notice what happened here. My factoring came out to be 5 times 3z minus y, x plus y. Okay, so that's factoring by grouping. We had four terms. We group the first two and the last two. We factor out the greatest common factor from the first one. And then we try the second one and hopefully get the same factor over here. And if we do, why then we can apply the distributive property to complete our factorization. And notice how we have one polynomial times another polynomial, well, times a number actually, that will result in this original simplified expression. Factor by grouping.